So okay. So first of all, I want to thanks to the organizing committee members to give me the opportunity to present my work here at international level. So the title of my talk is Photocatalytic Applications and Cyclic Voltammetry Study of Nickel Pyrophosphate Nanoparticles. So this is the plan of my presentation. First, I will introduce the nickel pyrophosphate nanoparticles. After that, how to synthesize this material. After that, I will discuss about result and discussion part. So in this part, I will briefly explain structural analysis, wastewater analysis, total organic carbon, and cyclic voltammetry of the material. And after that, I will conclude my talk. Okay, so nickel pyrophosphate have monoclinic crystal structure, and it's a large applications. Nickel pyrophosphate having applications in energy storage devices as well as supercapacitor. It is also used as efficient photocatalyst for hydrogen generation from wastewater splitting applications. It is also useful for battery applications, and it is also used as a catalyst for dark degradation. So in this talk, I will cover this first one and last one application for the particular material, that is nickel pyrophosphate nanoparticles. Now, how to synthesize this material? So to synthesize this nickel pyrophosphate nanoparticle, first we took 0.5 molar nickel chloride solution, stirred it for 15 minutes. After that we added triton X100 as a surfactant in this homogeneous nickel chloride solution. After that we added sodium pyrophosphate solution 0.25 molar as a drop-wise manner in this nickel chloride homogeneous solution, and after that filtered it, and we got the green precipitate of nickel pyrophosphate nanoparticles, and after that calcined this material at 300 degrees Celsius in the furnace, and after that we got the final material. So this is the XRD plot, and these are the lattice constant. This XRD plot well matched with the BZBS card of the material. This peak broadening indicates the nanostructured nature of the material, and from the Searer's formula we found the average crystallite size near about 15.48 nanometers. Now the TAM analysis. So from the TAM images, we conclude that the minimum particle size of the material, that is 3.19 nanometer, and the maximum particle size of the material, that is 57.27 nanometer. And also this images shows the spherical, near about spherical morphology. Wastewater analysis. So this both the figure shows the effect of pollutants on aquatic system. So the dyes exist in industrial wastewater and even in drinking water system, which are extremely dangerous to the environment and humankind due to their toxicity and resistance to natural degradation. Furthermore, when light penetrates in water will be hindered and photosynthesis in aquatic plants will be disrupted in presence of dyes. This will kill aquatic life and hence also affect the ecosystem. So, now I will briefly explain the mechanism of MB dye photodegradation. So, methylene blue solution, under the illumination of the light, the mass energy is higher than the photocatalyst band. So, the electrons from the valence band is excited and goes into the conduction band, and therefore it will create the electron hole pairs, and these pair will initiate a series of reactions and produce hydroxyl and superoxide radicals anions. For the methylene blue dye is common as an organic pollutant, so the photocatalytic activities were evaluated by decolorization and degradation of 10 ppm of MB solution, which is prepared by adding 10 mg methylene blue in 1000 ml water. Okay, so now this is the chemical formula of methylene blue dye. For UV radiation, the immobilized photocatalyst 200 mg was placed inside a beaker under the continuous stirring in a dark condition. Then the beaker containing MB solution and nickel pyrophosphate catalyst was exposed at 76 microwatt per centimeter square intensity produced by UV lamp, which was homogenized by a magnetic stirrer. At same the process, the distance between UV light and the beaker, that is 15 centimeters. The beaker was exposed under the UV radiation for 30 to 40 minutes with a stirring rate 200 rpm, which gave complete adsorption on nickel pyrophosphate catalyst. However, it is required to be noted that when the experiment was repeated in the direct sunlight, the decolorization took long time. It is near about 4 to 8 hours. Now, these are the wastewater analysis data. So, from these data, we observed that the chloride concentration is double. The chloride concentration is double in the degraded MB solution. The slight increase in sulfate and slight increase in sulfate concentration suggested that the dye is degraded in lower molecular weight. On the other hand, that is phosphate and nitrate concentration reduces in the degraded MB solution. This leads to conclusion that the photodegradation affects chloride, sulfate, phosphate and nitrate concentrations. Now, these are the TOC data. So, these TOC data suggested that during the decolorization step, there was obvious decreases of TOC values, which was due to the fact that MB molecules were decomposed to the intermediate product and the further oxidized to the intermediate product simultaneously. The mineralization efficiency was also calculated by estimating the TOC data, and the mineralization efficiency is increases as the irradiation time is also increases, and which is very good, and we got very good efficiency of mineralization at the degraded MB solution at 90 minutes. Cyclic voltammetry to determine the electrochemical capacity properties of nickel pyrophosphate nanomaterials. Cyclic voltammetry experiments within 0 to 0.6 volt range at a scan rate from 5 to 100 millivolt per second were performed in 3 molar KOH electrolyte at room temperature. On the basis of their energy storage mechanism, supercapacitor can be classified as electrochemical double layer capacitor and pseudo capacitors. In EDLC, that is double layer capacitor of ions is created at the interface of the electrode surface and the electrolyte, while in a pseudo capacitor, energy is stored through fast surface redox reaction which take place at the electrolyte interface. From the EDLC and pseudo capacitor mechanism plots of charge transfer type A, B and C. So from these type and the graph of current versus potential, the behavior, the graph of this behavior, we conclude that the which type of our capacitor is work. This is the cyclic voltammetry plot. This is current versus scan rate plot. So nanostructure electrode is based on the surface redox mechanism of nickel 2 plus to nickel 3 plus at the surface, and the shapes are different from the EDLC, suggesting that the capacity mainly results from the pseudo capacitive capacitance. With increasing the scan rate, the peak current shows a linear increment denoting high electron swift and ions in the nanoparticles. This is the capacitance versus scan rate plot. So from this plot, we observed that the maximum specific capacitance found to be near about 406.33 for the scan rate, that is 5 millivolt per second, while the specific capacitance is decreases as the scan rate increases, and the lowest value of the capacitance is 49, near about 49.5 for the 100 millivolt per scan rate. The specific capacitance decreases with increase the scan rate, may be due to the rapid mobility of the charged particles. Galvanostatic charge discharge GCD curve. So from this plot, non-linear related to the potential, suggesting the presence of the both capacitive and battery type process in the devices. The value of specific energy and specific power found from these two equations, and the specific energy and specific power are two key factors for the evaluating the power applications of electrochemical supercapacitor. Good electrochemical supercapacitor can provide high energy and specific capacitance. So the value of this specific energy and specific power are very good. So now I conclude my talk. So the nickel pyrophosphate nanoparticle calcined at 300 degrees Celsius. Photocatalytic activities were evaluated by decolorization and degradation of 10 ppm of MB solution, which was prepared by adding 10 mg methylene blue in 1000 ml water. From wastewater analysis data, the slightly increase in sulfate ion concentration was observed, while for chloride concentration found in degraded MB dye was twice that of pure Mb dye solution. Thus, the drastic change occurring in the chloride concentration suggested that the dye was degraded in lower molecular weight, that is luso dye. TOC study employed to evaluate mineralization of Mb dye. The mineralization efficiency increases as irradiation time is increased after 90 minutes of constant stirring of Mb dye and the catalyst solution. The efficiency was found to be near about 83%. Ion chromatography technique suggested that the degraded in lower pseudo dye from CV analysis conclude that the nickel pyrophosphate exhibits the faradic and pseudo capacitor behavior, and nickel pyrophosphate nanoparticles can be used as a supercapacitor. Finally, I want to acknowledge my PhD guide Mihir Joshi sir, who helped this in all work. I also want to acknowledge here Professor P. Keja, Head Department of Physics, MS University. I also want to acknowledge R. Jayavel sir, Anna University, Chennai, to provide the CV data. And also like to acknowledge here Head Department of Physics, Saurashtra University, and also my senior colleague P.D. Solanki for their help. Thank you so much for your kind attention.
So what's your name, sir? Yeah. The one who is presenting on behalf of Dr. Kripa.
My name is Praveen Kumar Pandey. I am a research scholar. My supervisor, Dr. Kripa Mishra.
Okay.
So, introduction. So, ionic and electronic contribution to total electrical conductivity has already been obtained through the time-dependent study of DC electrical conductivity of the studied material. It has been observed that ionic contribution to the total electrical conductivity increases with temperature, but it remains less than 97% below critical temperature. Critical temperature also may face transition temperature, but above critical temperature, this contribution certainly increases and becomes more than 98%. This clearly indicates that a studied solid has two phases, one below and another above critical temperature. Thus, the critical temperature may be termed as phase transition temperature. This is the data from total conductivity, electrical conductivity, and ionic conductivity, and ratio of ionic to electronic conductivity. Here is the log sigma versus temperature of Na4TiO4 from different temperature, 600 Kelvin, 800 Kelvin, and 1100 Kelvin, and different energies. This is the ratio of ionic to electronic conductivity of Na4TiO4 log R of temperature. The phase below the transition temperature has predominantly ionic conduction. We call it normal ionic phase. The phase above Tp has almost entire ionic contribution to the electrical conductivity with almost negligible electronic contribution in studied compound. In this phase, temperature greater than phase transition ionic conductivity in Na4TiO4 compound, the ionic conductivity remains of the order of 10⁻⁻1 omega inverse meter inverse, which is not high enough as expected for the superionic phase. The Na4TiO4 compound do not show the superionic phase. This is the graph of log sigma T versus temperature. As temperature increases, then the graph will decreases. This is the phase transition of the Na4TiO4 770 Kelvin. This is ionic conductivity. This is ionic conductivity, and this is electrical conductivity. This is total conductivity of ionic and electronic conductivity. To confirm the nature of mobile ions, we look at our thermoelectric power. Started the thermoelectric power is negative in the entire study temperature range, and thus, as per our convention, the mobile carriers are positively charged. Two types of positively charged ions are there in Na4TiO4 compound, namely sodium ions and titanium ions. Due to their high positive charge, titanium ions are expected to be mobile, where sodium ions have no positive charge and small size are expected to show greater mobility. The general transport mechanism of such ions expected to be hopping. However, intrinsic hopping conduction of these ions from normal lattice site to the other lattice site is least probable because it will be involve high activation energy, 5 electron volt or more. Hence, electrical contribution is probably due to hopping of the defect. The value of current in both region is high, indicating that only one type of charge carrier is responsible for electrical conduction. As indicated by thermoelectric power, the nature of charge carrier is positive. Therefore, it appears that there exists a large number of Frankel defects, even the normal ionic phase of the studied solid, and they may be further generated at higher temperature. But at lower temperature, that is in normal ionic phase, the thermal generation of the appreciable number of Frankel defect is less probable because higher energy involved in their generation. In such situation, the variation of sigma T versus temperature by sigma T C1 exponential HF upon KT, where C1 is temperature dependent constant and HF is enthalpy for the migration of mobile ions. A is actually enthalpy of the migration of mobile defect. This is the data of Na40 of electrical conductivity compound. This is the thermoelectric power data and temperature dependent constant mobile science enthalpy. This is the data. We calculate thermoelectric power and log sigma T from this formula, where Q is the heat of mobile ions and H is constant. This is the conclusion. The value of activation energy are relatively high, 0.6 electron volt even at high temperature, against the value of 0.3 electron volt expected for supersonic solid. With the ionic conductivity also low, 10 ⁻⁻1 homogeneous meter inverse, which is smaller than the expected for supersonic solid. No doubt the compound Na40 undergoes a phase transition around 770 Kelvin and yield a high ionic conductivity, but in two sense, the Na40 are not supersonic solids.
Good afternoon, sir. Good afternoon to everyone. I am Dr. Twinkle Keshari, working as assistant professor in Veer Kuvar Singh University, Ara, Bihar, India. I am going to present my work, Organic Synthesis via Visible Light Catalysis in Context to Pyrrolidine. So we all know about catalysis. What is catalysis? We know the definition that catalyst accelerates the reaction without undergoing any change. Here we are talking about photocatalyst, which is a material that converts light energy into chemical energy by absorbing photons. Commonly, photocatalysis is a process that involves the absorption of light by catalyst to initiate and boost up chemical reactions. So these are common reactions by visible light, which happens naturally, like alcohol oxidation, natural compounds reduction, hydrocarbons oxidation, and amines oxidation. Our approach here is catalytic activation of organic molecules that has received much attention recently is visible light photoredox catalysis. In a general sense, this approach relies on the ability of metal complexes and organic dyes to engage in single electron transfer processes with organic substrates upon photoexcitation with visible light. Many of the most commonly employed visible light photocatalysts are like polypyridyl complexes of ruthenium, iridium. Also, there are many dyes like rose bengal, eosin Y. These are the structures of the photoredox catalysis, which are being used in visible light photocatalysis reaction for organic synthesis. Facial iridyl polypyridyl and ruthenium salt of bipyridyl, rose bengal, eosin Y. These two are dyes and others are traditional metal complexes. So the main photochemistry of photocatalysts. Many organic molecules may function as visible light photocatalysts analogous to metal complexes such as bipyridyl ruthenium complex, organic dyes such as eosin Y, and many others are also there. These catalysts have been employed to achieve a vast range of bond-forming reaction of broad utility in organic synthesis. What they actually do, upon absorption of photon in the visible region, an electron in one of the photocatalyst metal centered T2G orbital is excited to a ligand centered pi star orbital. The excited ruthenium photocatalyst, here I am talking about ruthenium because the reaction which I have done is carried out by using ruthenium photocatalyst. So the excited ruthenium photocatalyst undergoes either reactive or oxidative quenching reaction to complete the reaction mechanism. Dihydropyrrolidine. Why it is important? Because there are many natural compounds and pharmaceuticals with a variety of biological and therapeutic activities contain unsaturated N heterocycles such as pyrrole and its derivatives. As a result, they have attracted dihydropyrrolidine. Many natural compounds and pharmaceuticals with a variety of biological and therapeutic activities contain unsaturated unheterocycles such as pyrrole and its derivatives as common structural motifs. So that this is the reason why synthetic community has been working hard to create extremely effective synthetic methods to obtain these compounds. There are many literature reports for the synthesis of dihydropyrroles. Some are mentioned here, like cycloaddition of sulfonamide anions, ring expansion of iminocyclopropanes, hydroamination, double and alkylation. But to the best of our knowledge, our method, which is the use of visible light photocatalysis for 3+2 cycloaddition of alkynes with aziridine, has been new. So we have used aziridine with and alkynes for 3+2 cycloaddition in the presence of ruthenium photocatalyst, in the presence of blue LED, nitrogen atmosphere at room temperature to give our product. Our model substrate for N-tosyl aziridine 1A and phenyl acetylene in the presence of blue LED, the wavelength of 475.5 nanometer, and the photocatalyst which we have used here is 2 mole % of ruthenium bipyridyl chloride photoredox catalysis. On getting our desired product, we have further optimized the reaction condition by using several other photocatalysts like eosin Y and ruthenium bipyridyl tetrafluoroborate. Other oxidants were also used like ammonium persulfate, iodine, DDQ, NBS, sodium persulfate, potassium persulfate, and phenyl iodoacetate. We have also varied solvents like THF, DMSO, and DCM. So this is the table showing all the optimization conditions we have used here. In this entries, we can see the 7th one. We have used eosin Y, which is an organic dye, also a photocatalyst, in which the our product was 41% in yield, which is less than our desired product. The most suitable one, condition is we can see in 5th one. We have used ruthenium bipyridyl chloride, and we get 80% of yield. On switching to tetrafluoroborate, ruthenium tetrafluoroborate, in 8th entry, we can see we get 83% of yield. So this was also much better than the ruthenium bipyridyl dichloride. In the absence of the photocatalyst, we can see the entry 17. We were getting traces amount only. So this shows that the photocatalyst is important for our reaction. Also, in the absence of light, we can see the entry C. In the footnote, we can see the C. I have written here no light. So in this 3, yes, in this we can see the traces amount of. So the visible light and photocatalyst both are very important for our reaction. In entry 11, we can see here F. Uses of other oxidant like iodine, DDQ, we were getting only 40% of yield. Sorry, here we can see the yield were reduced. So this also shows that our desired condition for the best condition for the reaction is the use of ruthenium bipyridyl tetrafluoroborate, oxidant benzene diazonium tetrafluoroborate in the presence of solvent isopropanol. We were getting 88% of yield. On getting optimized condition, we have further worked on the different substrates we have carried different substrates of aziridine and also alkynes. So on varying the substituents of aziridine, we can see in the entries R1, R2, R3, R4, we have used different substituents. In the presence of fluorine, chlorine, and methyl, we can see there is not much change in the product yield. It is from 91 to 74% of yield. In the presence of alkane compound, like we can see here octyl, the yield was reduced to 35%. Similarly, in the presence of N-tosyl cyclohexane aziridine, also the yield was reduced to 55%. So aliphatic compounds were not so tolerated. Next, we have used different alkynes, different substitute alkynes. And alkynes we have used, we can see here for methyl, alkyl, fluorine. So in all this case, the yield was good to better. Instead of use of dialkyl alkyne, we have used here in entry 7, we can see the product 3R is very low. So in both condition, in both substrate condition, we can see the use of aliphatic compounds has reduced the yield. Now we can come to the mechanism. In mechanism, we can see here in the presence of visible light, ruthenium photocatalyst get oxidized. First of all, it get excited to ruthenium star 2. 2+, which is then oxidized by phenyl diazonium salt to ruthenium 3+. So this is oxidative quenching cycle. Earlier I was telling that the photocatalyst reaction mechanism which undergoes through 2 steps, either by oxidative photoquenching cycle or by reductive photoquenching cycle. So this one is oxidative quenching cycle. Ruthenium here is oxidized by phenyl diazonium salt, which itself undergo dimerization to product a biphenyl compound. After that, ruthenium 3+ is again reduced to ruthenium 2+ by the aziridine. Now, aziridine 1 get converted to amine radical cation 7, which is attacked by the alkyne second to form a intermediate 8. We can see here after hydrogen atomic transfer. It undergoes cyclization to form our product dihydropyrrolidine. So this is the mechanism overall. And the characterization of the compound has been done by the taking NMR, proton NMRs, carbon NMR, and mass spectra. So after concluding, I can say that in summary, we have developed a visible light triggered 3+2 cycloaddition reaction of aziridines with alkynes under simple and mild reaction condition with a wide range of substrates. The reaction is scalable, uses low catalyst loading, is highly reduce-selective, and provides a variety of polysubstituted dihydropyrroles in moderate to high yields. Visible light is a clean energy source. Make this route a good substitute to other existing synthetic protocols. Thank you, sir.
Yeah.
Thank you.
Yeah,
Is it
now it's
visible?
okay.
Now it's okay. Yeah.
Okay.
Yeah.
Make it to full screen if possible. I mean,
Let me.
Else you can continue.
okay, you can continue with this. Yeah. Yeah, you can continue with this.
Okay. So, good afternoon, Chairman of this session. I, Professor Manas R Panigrahi, Professor of the Department of Physics, Bir Surendra Sai University of Technology, right? Going to present a topic on fabrication, structure, and optical properties of 100% DY-based BZBS double perovskite material for applications in solar cell. Actually, this is a present work that we are undertaken for my PhD scholar, right? It's a fresh work. And here, this is the content of my presentation. First, I will introduce what is double perovskite, then its structure, importance, objective, experimental technique, characterization, and conclusion. Double perovskite materials are definitely better than the single perovskite material, and it is our material is in the form of A2BB'O6. Basically, double perovskite material is synthesized or prepared based on the certain formula called the tolerance factor. The tolerance factor I have not written here. It is Ra plus R prime, that means the cationic ionic radius of the two cations plus R0 divided by under square root 2 Rb plus R prime by 2 plus R0. R0 stands for the oxygen radius. Now, if this T factor is a range, actually, it is not a single value, it is a range, and if it lies between 0.88 to 1.04, then this material is stable. Otherwise, they are unstable. And again, if this tolerance factor is more than 1, then they belongs to tetragonal and orthorhombic stage crystal structure. And if it is less than 1, then usually they are rhombohedral and monoclinic structure. But in our case, it is orthorhombic. That means the tolerance factor is more than 1. And exactly for this particular material, if I calculate, then the tolerance factor is coming out to be 1.02. Now, due to the paucity of time and the space, I have not going in details of those structures. Here, I am actually explaining you the experimental flowchart. First, actually, I am explaining here a very unique way of synthesis process. We are not going to the traditional way because there are so many processes for synthesis of the material, like your solid state reaction, sol gel, or wet chemical, hydrothermal, coaxialate, co-precipitation, solvothermal, autoclave, and many more. But out of these, I have chosen this specific modified sol gel technique. This technique is called the modified sol gel technique because here in this technique, we are not using the traditional solution of the reagent. We are starting our experiment with the powder reagent. Then this process explains that after taking the stoichiometric proportion of the powder reagent, we are making a lump-free paste. Then you are stirring that with addition of the demineralized water for uniformity and continuous stirring and heating. Here we go for the peptidation. Now, once the peptidation is achieved, we'll get a sol. And once the sol is formed at this particular stage in continuous heating and stirring for almost approximately for 3 hours continuously at a temperature of say 80 degrees centigrade, we get the sol. A sol means the material gets settled down and the upper portion, 3/4 of that will be clear transparent water. Then in order to remove that water portion, we add 1 molar nitric acid for refluxing of that water. And along with that, if you go on continuously stirring and heating at a temperature of say 220 degrees centigrade, then we get a gel after 3 hours, a uniform gel, very silky gel, right? It is actually, you can say, aerosol also. Now, that particular gel was allowed to dry for some time, or sometimes at almost 2 hours or so. Then we can take it out and grind in Nagat mortar to get the fine powder. Okay, then that fine powder is subjected to XRD, and this is the characterization part of the XRD. Here we have taken 2 samples. One is BZBS and the other is 1% divide doped BZBS. Now here there are many peaks. They are basically perovskite structures, right? And here they almost match with each other, and there is some evolution of small, very small peaks. Here I have not indexed with the plans, right? Also not given much structural data. I have given a very limited data here. ABC parameters, crystallite size, microstrain, the size square value after refinement, and the orthorhombic crystal structure after refinement only. Right here it is seen that when you are doping the material with dy, the volume decreases, and automatically this ABC parameters also decreases, and they belong to the same group, but the crystallite size is increasing. Microstrain size is very less. Okay, now this is the structure, and it speaks about that they almost lie in the singular phase, and there are also evidences of trace phases. Here, if you see these basic trace phases, sometimes the intensity of the peak is more at that particular point, whereas that is not that high in case of the NAV BZBS sample. BZBS here stands for, as I have already told you, this is your barium, zinc, bismuth, strontium, and dy is your material doped. Then subsequently, in order for to know the photocatalytic activities, we have taken the UV beach characterization, and here this absorbance spectra and the transmittance spectra, as they are correlated, you know that relation. It is found that this is within the visible range from 300 to 900 we have taken. Here it is almost linear, and this particular point and this point, it shows a very deep bond, and here there is a kink. This is here, it speaks about the low absorbance, and this is the maximum absorbance of the material for both the synthesized material. And of course, this absorbance and transmission, they are related to each other. Right. Then we can go for, these are very fundamental things. Then we can calculate the refractive index and the extinction coefficient from using this formula. All the values of this parameter, whatever we have calculated, I can show you at the conclusion and how they are varying with the doped material. Now the extinction coefficient, here we are find out the refractive index with this parameter. This is the reflectance, and here K alpha by 4 pi, right? Here you can see the extinction coefficient from this particular region, almost around 500 nanometer wavelength. The extinction coefficient is almost linear, and it goes off, right? Similarly, in order to find out the band gap, we have used this formula, and I elongated the linear portion, which touches the energy axis at a particular point. For this undoped one, it is 2.46 electron volt, and for doped, it is 2.36 electron volt. So there is a variation of 0.1 electron volt of band gap, and this is actually a large band gap material, so highly suitable for photocatalytic activities or solar cell fabrication. Now, in this particular case, we are taking help of the tau plot. Tau plot speaks about the direct and indirect allowed transition band. This n parameter here in this equation, this n, if it is half, then it goes to direct allowed transition. If it is 2, then it is indirect allowed transition. If it is 3/4, then it is direct forbidden transition, and 3, then indirect forbidden transition. And in case of your direct forbidden transition, the energy and momentum, they get conserved. What happens here? The energy and momentum, they get conserved because in this case, it is a direct allowed band gap. Now we'll go to the next slide. Now here you can find out the very interesting part of this is that we can find out here the dielectric constant. The dielectric constant. Here you see the dielectric constant is negative. The dielectric constant is negative. So what does this negative dielectric constant say? Negative dielectric constant, this is the beauty of this material. Dielectric constant based on ion conducting material. Negative dielectric constant material is an essential key for creating metamaterials or artificial negative index materials. It attracted the attention of the scientist because hardly natural negative dielectric constant material exist, and they are basically used for your solar cell formation with high efficiency. In addition to this, we have found out here the interband transition strength. The interband transition strength means you see here of different. This is the real part and imaginary part. Both are plotted. This side, this is the real part of the interband transition strength. This is the imaginary part of the interband transition strength. And here they actually follow a patterns, right? Increasing this side here according to this one, red and blue, they continuously increasing. Then they attain a particular peak, decreases at around 3.4 electron volt, which is the minimum energy of the absorption in the absorption spectra. Then they again increases. Of course, this imaginary part, we make use of this in calculation of the dielectric constant situation. Now this is the surface energy loss function and volume energy loss function, and for this we have make use of this formula. And this energy loss function from the surface and from the total bulk material, and this relation indicates that this loss function is again, you see maximum here at 3.4 electron. Again here it is minimum. Then it is abruptly increasing, and here it is decreasing. This is about the Orbach energy. Orbach energy speaks about the disorderness of the material. It is a crucial measurement, and it follows and it is related to the absorption coefficient h nu by EU. EU represents your Orbach energy, and this Orbach energy is nothing but this particular section, the linear section. And here this is the regression part, and this regression part speaks about our values, and the Orbach energy for the undoped material is 0.29, where it is for doped one, it is 0.22. This is your optical conductivity and the electrical conductivity using this particular equation that alpha AC is 4 pi and 2 lambda optical conductivity by alpha. We can find out that the optical conductivity of the material is maximum here at this particular point, say around 3 electron volt. Again, it is at 3.4 electron volt, but basically this particular region, which is towards the receipt, towards the origin, we are not considering. We are simply concentrating on this part. Similarly, here, if you see at 3.4, it is the electrical conductivity is almost uniform here, but it is decreasing continuously. This is decreasing continuously, and all these electrical and optical parameters, they are calculated based on the EBBS data. There is no any other calculation. We are simply calculating from the spectroscopic data. Here, you are finding out in this particular equation, this ED and E0 is oscillation energy strength and dispersion energy strength. And this is again with respect to the energy spectrum, this oscillation energy strength, and this one here after the regression, we can see that the oscillation energy is 5.7 in case of your undoped material, where it is 4.85. And dispersion energy is 48.85, here it is 41.17. So whatever the parameters that you are calculating, they are little less as compared to the undoped material. So the doped material, oscillation energy, if it is more, then it will create some problems or the fluctuations of the current. But basically, when it is less, it is suitable for solar cell fabrication. Now, here we are finding out the electrical susceptibility, and this is the reflection loss. This is the reflection loss. There are many other parameters also that we can calculate, like pan energy, frequency wavelength, energy gap. Yes, there are many other parameters that we can calculate, but we have not included all those things here, only because of the restriction to the 15 number of slides and 15 minutes also given. So finally, we are concluding that these are the parameters. This material is prepared by a unique sol gel method. This method, you can hardly find any literature for this except our papers, because we have published this method as a, you can say, established one in Journal of Sol Gel Science and Technology, right? Since 2014, I am doing my experiment with this method and published almost 18 papers with sol gel method only, this modified sol gel method only. Also, I have awarded 3 PhD students with this method. Now, the XRT results say that the material crystallizes in orthorhombic structure, right? And there is no rampant evolution of the foreign peaks. So we have also synthesized the ICD data file of the BZBS material. They show good matching with the existing data file. And optical properties, you have taken the UV spectrophotometer from 300 to 900 nanometer range. And these are the parameters that we are getting. This is the absorbance, then transmittance, you see band gap, Parvak energy, oscillation, diffraction, surface energy loss, and volume energy loss function. Now, if you compare here, then almost all the parameters, they are on the lower side for this divided material, which makes this material a suitable candidate for solar cell applications. Of course, many other parameters we have already calculated, and we are communicating this to the journal for consideration. But this is a new material that we have taken off, and probably we'll be able to complete this by the end of this month, because some time and SAM figures we are waiting for, we have not yet received. Otherwise, I could have shown that whenever you are doping with the DY, then the grain size also changes. Crystallite size is changing, no doubt. It is more in that case, like I have shown you in the slide number 3. So in that particular variation in the crystallite size and non-existence of the defects, that also says that this material is suitable. Here there is no stacking fault, and whatever the variation is there, that is because due to the crystallographic orientation of the material, and you can say the rearrangement of the oxygen atoms, because there are a good number of participating atoms. So B, Z, Vs, this is barium, zinc, bismuth, strontium, and Dy. Right. So because of this, this shows a very potential applications. And here also, in order to be applied in the field of solar cell, we have calculated the fill factor, efficiency, short circuit current, and open circuit voltage. Out of this, the efficiency in this material comes out to be 18.75, which is a very promising efficiency for the solar cell applications, which we are planning to design the solar cell in near future. These are my references. Thank you.
So, myself, I am Prakash Gadipelli. I am assistant professor in the Department of Chemistry, Aditya College of Engineering and Technology, Surampal. So, with 9 years of experience in the academic years in the engineering discipline, I focused on generally my research area is related to material chemistry, analytical chemistry, and polymer chemistry and synthetic chemistry. So now I here explain to the topic on sustainable synthesis of imine derivative from furan to carbolhydrate, a single step environmentally benign. The method is antioxidant assessment. So according to the general, if you go for the introduction in the study, the synthesis is sustainable synthesis, which is related to green chemistry. A single step method is used to produce a imine derivative. The reaction in between the furan 2 carbolhydrate and 7-ADCA. The 7-ADCA is 7-amino deoxycephalosporic acid. In between the two reactants undergo the reaction, which give a synthetic product, that is imine derivative. Okay, here the biomass of the compound that is furan 2 carbolhydrate is derived from the lignocellulose products. Okay, which is the product is eco-friendly product, which is environmentally sustainable product. reactant. Okay, then here in this method, if you are going to be used the solvent, that is ethyl alcohol, that is also reducing the environmental impact, which is convention for the synthetic process. Okay. Also, the focusing of the utilization of 7-ADCA, that is 7-amino-deacedoxycephalosporic acid, and our reactant Furan 2-carbolate, which is synthesizing based on the Schiff's base. Okay, the synthesis is finally we got the product after combination of the reactants, which is clearly give a thick brown color product that is finely powdered. Okay, mainly the product which is exhibits the melting point about 159 degrees centigrade. Okay, the finely powdered agglomerated with the form of spherical shape, which gives a powdered shape of the product, which is determined to be the 450 nanometers in the UV region. Okay, yeah, the applications of the product, imine derivative product, which is majorly pharmaceutical and material science, contributing the eco-friendly, it is used. Next, forward to the importance of the study. Okay, mainly the product is growing about the discovery of the revolutionary molecules in the early phases of the chemical revolution changed daily, leaving the rise worries about the growing environmental contamination. By the contamination of two reactants, we are going to be produce a new molecules which is useful to the environment, which does not affect the environmental contamination. So we lead to we go for the synthesis, which is safer chemicals which are used to combined. Okay. In address to the chemical pollutants in the environment, there is currently rising support the company's direction of original combination of ecological friendly substances, the components rather than depending of the post-manufacturing corrective processes. So we are going to be the combination of two reactants. We are go for the procedure parts, the combination of which is used, the combination of the ecological friendly substances going to be used in this synthesis. So why majorly the emphasis is now the sustainable synthesis techniques, which is help us.
The slide is not moving. I think you are on first slide or some other slide. Your slide is not moving.
It's moving, sir. Now?
No.
Escaping.
Yeah, now it is moving, sir.
Okay. Okay.
So you are on slide number 7.
Yes.
Yeah, moving. Okay.
Okay. The emphasis of the here the sustainable synthesis technique is majorly maximize the medication development, means the development of the products which is useful to the sustainable synthesis. Here is the procedure also used in the medicinal fields also. The chemical process strategies which minimize the environmental effect. Also, green principles also explains about that where the two reactants undergo the reaction, which is minimize the product, which is help us to the environment, which does not affect the environment. So we can able to undergo the process. And significant the work is significant is now by being done to the develop novel multi-component reaction. Wait, sir, no problem. I will change it. Okay, the development of novel component reactions and enhance current ones in order to enhance the area, lesser ecological impact and chemical operations. So the main goals is the sustainable and green medical fields. Okay, here is a slide which is explains the green chemistry principles. One is prevention, how the products are environmental affecting products are going to be prevented, and what is the economy of the atoms, and what are the reactants going to be safer for the environment, and what are the safer chemicals going to be designed, and what are the products going to be degradation in the environment and going to be used in the various types of catalysts going to be produce a new molecules and new which is help us in the discovery of the drugs, and which of the derivatives of the reactions which are going to be helps to degrade the and also the energy efficiency and chemical kinetic real-time analysis of the pollutions, reactions, and the accidentals of the preventions, which are these are the total principles which are related to the green chemistry, which allows to in the medicinal field, pharmaceutical fields, as well as in the synthetic chemistry. Now, now going to the synthesis of our product, we are going to be taken ethanol as a solvent and perfurol and 7-ADCA. These are the reactants going to be used, undergo the reaction, which finally gives a brown color, thick PPT color precipitation will form. That is imine derivative. Okay, here is the reaction explains. The reaction undergo the 90 degrees centigrade. Finally, we got the yield about 70% of the product, which is brown color precipitate. Okay, finally, the yield is calculated undergo the principle is yield of the percentage. Weight of the product is formed by the weight of the sample. That is perfurol we are going to be taken. It is multiplied with the 100. Okay, finally, we got the percentage of the yield. We are going to be using final complete the after formation of the product. We are going to be characterize that product with the help of melting point analysis, UV visible analysis, and FTIR analysis, NMR analysis. And also here it is the product going to be importance in the medicinal field as well as pharmaceutical fields, because of here exhibits a special character, antioxidants, as well as here exhibits a antifungal, anti-malarial activities that will also going to be analyzed by based on the reactants going to be used. According to the FTR spectroscopy, okay, here the FTR spectra completely gives a complete spectrum, which is means it's completely gives a functional group elements which are present in the product. Okay, finally, the wave range of the product, which is observed in between the 640 to 3300 centimeter inverse. Significantly, the compound contains hydroxyl groups, which occurs a sharp peak at 3331. Then the hydroxyl groups, which is exhibits in the product of the reactants in between the perfurol carbolide 7-ADCA. Okay, then here the compound also contains aliphatic hydrocarbons, which is occurs a stretching vibration peak, which is occurs at 2920 I. And also the compound contains carbonyl group, which is occurs at 1644, and C double bond C bond H, and again the compound contains also amide group, which is major occurs in the 1330 centimeter peak. The wide range stretching vibration which occurs, which is related to the compound that is C double bond N amide group, which is related to 7-ADCA, which is occurs at peak occurs at 1330, and remaining the part of the functional group, which is the peaks exhibits wider vibrations, that is SIVO wider vibrations, which is the peak is occurs at 1152, and remaining part of the CH related compounds, CH related elements, the observing peaks at 1014 to 748 in between the range, which is completely related to the imine derivative product. Then next, after forward the analysis of NMR spectra, here the elemental analysis, which is carbon, hydrogen, nitrogen, sulfur, and oxygen. The formula of our product and molecular weight here, the color is of the compound will completely given here. The range of the aliphatic compound, which is occurs in between the range 1.1 to 3.3 ppm, which is related to only the compound contains aliphatic protons. The remaining the compound contains any other products, which is the peaks which occurs at 9.4 to 9.8, that is aromatic protons. Okay, if the compound contains any aromatic protons, the peaks occurs at the positions. Okay, here look at the product our carboxylate Jite Furan 2 imyl ethylene amino acid 4 methyl 4.27 axo 2 thiobicyclo, the carboxylic acid, actofurin fine, that is our product. Okay, look at the picture here. That is NMR's completely spectral
But
data.
please conclude your presentation.
Sir? Okay.
Please conclude your presentation. We are running
Okay,
out of
okay.
time.
Okay, sir. Complete final product. Here going to the conclusion. The complete product, which is eco conscious synthetic methods, we are going to be produce a product that is related to medicinal field, which is useful to which is exhibits a antioxidant activity as well as antifungal activity, which is addressing the oxidative stress related to the health conditions. So and we are characterizing the different functional groups through the NMR and FDI. Thank you, sir.
Thank you, sir. Thank you for a valuable presentation.